Hello everyone, today we're going to start the lesson 6.2 matrix multiplication, inverses and determinants. This lesson is an easy lesson, which is we are going to multiply matrices, then find the determinant and inverse 2 by 2 and 3 by 3 matrices. Okay, so now let's start with the first one, multiplying matrices. Now to multiply matrices, okay, we need first to know how we can add matrices. Adding or subtracting matrices is easy. For example, let's say we have matrix A and we have matrix B. So the new matrix after we adding this matrix will be this one here. Okay, how we can add matrix A with matrix B? It's easy, simple. Every single term or element will be added with every single element in the second matrix. So first example, matrix A 11 plus B 11. So the answer will be written here. 11 plus B11, then you write the answer. Same thing here, A12 plus B12, then you write just the answer here. Next, then A13 plus B13, then you write the matrix here, A13 plus B13, and so on. You continue until you get the whole matrix. Now, scalar multiplication. Scalar multiplication means when you have a constant multiply with the matrix. So for example, let me just give you a quick example. So let's say I have 2, 4, 6, and 5. And I have this matrix multiplied by 3. So now what you must do, you just multiply this one with every single number here. So 3 times 2 is equal 6, 3 times 4 is equal to 12, 3 times 6 is 18, then 3 times 5 is equal 15. So this is the new matrix. So you just multiply every the constant, as you can see, the constant multiply every term, so you can get the answer here. Same thing here, k times a12, it will be ka12. Then the same idea, k times a13, ka13, and so on. So this is the scalar multiplication. Now this is the matrix addition, subtraction, and the scalar multiplication. Now let's go to learn how we can multiply the matrices. First and important step. So this one is the important rule that you need to write it. First, let's say matrix A, dimension is 3 times 2. And the dimension for matrix B is 2 times 4. Now, if the two matrices, okay, they don't have the same row in the first matrix, okay, sorry, the column, number of columns, okay, number of column in matrix A should equal to number of row in matrix B. So this is what we need to read. The number of column in A must be equal to the number of rows in B. What's that mean? Just a quick example. Let's say I have this matrix. So for example, let's say I have matrix A 2, 3, 5, 4, 3, 6, 2, 6, 7, 9. So this is matrix A. Let's say I have matrix B is equal to 5, 6, 7, 1, 8. So let's say I have this matrix A, matrix B. Now, what the first step that you need to do, the dimension. What's the dimension for matrix A? Dimension of matrix A is 3 times 3. Now, what's the dimension for matrix B? It's 2 by 3. Okay, don't forget, you start with column. The first number represents the row. The second one is the column. Okay, sorry, you start from the column, not the row. You start from the row, not the column. I'm so sorry. Okay, so the first number is the row. Then the second one is the column. Don't forget, okay? Now, as you can see here, we have 1, 2, 3. So as you can see, we have 3 rows. How many columns do I have? I have 3 columns. So 3 by 3. Now, look to this one. 2 rows. And how many columns do I have? 3 columns. Now, check this out. This we have a 3. And here they have 2. Are they equal? Okay, they are not equal. So we can't multiply them. So they should be equal. It's mentioned here they should be equal. Now, how can they be equal? Now, if I switch the matrix, okay, if I change the matrix B, okay, let's change matrix B. And I write, for example, matrix B is 5, 2, 3, 1, 0, 9. Okay. Now, what is the new dimension for matrix B? Okay. Dimension of matrix B is 3 times 2. Now, check this out. So here is a 3. Here also is a 3. So are the number of the column in matrix A equal to the number of the row in matrix B? Yes. So we can multiply this matrix. Now the new matrix, what's the dimension for the new matrix? What do you think is the dimension for the new matrix will be? Okay, after we multiply A times B or B times A. Okay, the dimension will be taken from the other value. So these are the dimensions. So as you can see, after we multiply, so as you can see here is 3, here is 2, so the new matrix will have 3 rows and 2 columns. Okay, 3 times 2. Okay, I hope you understand this. Now let's learn how we can multiply the matrix. So example 1, use matrices A and B to multiply, find each product. Product means what? Is to multiplication. So first step, A times B. Matrix A, let's write it down, 3, negative 1, 4 and 0. Matrix B is equal times matrix B, negative 2, 0, 6, 3, 5 and 1. Okay, then we close. Now let's multiply them. Before you start, you need to identify the dimension. What's the dimension here? It's 2 by 2. Here, what's the dimension? 2 by 3. Don't forget, number of rows times number of columns. And as you can see, this is 2, this is 2. So they are equal. So we can multiply them. Now, first, before you multiply, you need to identify the dimension for the new matrix. So the dimension for the new matrix will be what? What do you think it will be? So it will be 2 times what? Times 3. So 2 times 3. So I will have 2 rows. And how many columns will I have? I will have a 3 column. Let's make it more bigger. So I will have a 3 column. Now, let's multiply. So the rule said, every column with every single, every row with every single column. So for example, I have here the first row, okay, should be multiplied by the first column. Then we write, okay, let me change the color. Let's make it yellow, better than purple. So the first row with the first column means 3 times negative 2, then 1 times 3. Okay, then we add them together. So 3 times negative 2, negative 6, plus negative 1 times 3 is negative 3. So this is the first value will be here in front of you. Okay, I hope you get that. The second one is, let's do it in a purple. Okay, so negative 3 times 0. Then negative 1 times 5. So the second one will be 3 times 0, okay, which is equal 0, plus 1 times 5, which is equal, negative 1 times 5, which is negative 5. Then we add them. So this is the second one. Then after that, let's do the third one. So 3 times 6, then negative 1 times 1, okay, again 3 times 6, which is equal 18, plus 1 times 1, negative 1 times 1 is negative 1. So we write that. Okay, I hope you got the idea. The idea is clear and easy. Yellow with yellow, purple with purple, and blue with blue. Okay, let's do the same thing. Okay, so now after we finish the first row, now we need to do the second row. The second row has follow the second row here. So the second row, 4 with negative 2. Okay, 4 with negative 2, then 0 with 3. Okay, 4 times negative 2 is equal to negative 8, plus 0 times 3 is 0. Then the second one is 4 times 0, which is equal to 0, plus 0 times 5, also still 0. Let's continue. 4 times 6, which is equal to 24, plus 0 times 1 is equal to 0. So now the new matrix will be, let's write the final matrix after we simplify. So negative 6, negative 3 is negative 9, then negative 5, then 17, then here negative 8, then 0, then 24. So this is the new matrix after we multiply matrix A with matrix B. Okay. Now how about if we multiply matrix B with matrix A? Okay, don't just say no solution. Don't mention that. You need to try first to try the matrix. Negative 2, 0, 6, 3, 5, and 1. Then times matrix A is equal to 3, negative 1, 4, and 0. Now let's do it. What's the dimension here? Dimension is this 2 rows times a 3 column. Here 2 rows times 2 column. As you can see, here is 2, here's a 3, so they are not equal, okay? So no solution. We can't multiply, we can't multiply 3 by 2 and you can get a matrix 2 by 2. Okay, I hope you understand the steps. Now it's your turn. Try to solve this question, and these are the answer for you. Okay, and if you have any question, please ask me. Now, let's go to the next one. Identify the matrix. So identifying the matrix, okay, it's similar to what we did in 6.1, which means we need to write the augmented matrix. Okay, first step. First step, we know that we need to write the augmented matrix. Okay, so this one represented by A. Then we write the variable. How many variable do I have? If you check here, I have x1, I have x2, I have x3. Same thing here, x1, x2, x3. So the variable, the only variable that I have, x1, x2, x3. So I have a 3. So I write them as in this form here. x1 over x1, x2, x3 in one column, which is 3 rows. Okay, so these are represented by x, and the matrix, augmented matrix, is A. Well, now what happened with the b's here, which is the answer? The answer will be written as B, okay, which is B1, B2, B3. So now the matrix equation, okay, the matrix equation is follow A times X equal to B. A is the augmented matrix that we already know, okay. Then X is only the variable that we have. Then B is the number which is after the equal sign, okay. So this is the matrix equation. Then how we can solve the matrix equation? So the first step we need to write, so as for example, let's say we have this example here. Now first step, write the system of equation as a matrix equation, A times X equal B, then use Gauss-Jordan elimination on the augmented matrix. First step is to write it as we know. We know that A times X equal B. First augmented matrix, so augmented matrix is negative 1 here, then 1, then negative 2. So negative 1, 1, negative 2. Then negative 2, 3, negative 4. Negative 2, 3, negative 4. Then 3, negative 4, 7. 3, negative 4, 7. So we finish from A. So this is all A. Times X. What is X? Check how many variables you have. I have x1, I have x2, I have x3. So I write x1, x2, x3. Okay? Then after that we finish from X. Now let's go equal B. So equal B. So what is B? B are the number after the equal sign. 2, 5, negative 1. So this is the matrix equation form. So this is how we can write the matrix equation. Then after that, just solve it as we did in 6.1. Okay, we write the augmented matrix. Okay, then we start make this value equal 1. Okay, by dividing the whole row 1 divided by negative 1. Then after that, I need to make this value equal 0 and this value equal 0. Then after that, I need to make this value equal 1, as you can see. Then I need to make this value equal 0. Then I get the answer, which is equal. X1 is equal negative 13. X2 is equal 1. X3 is equal 6. So the same way, but in the matrix equation form. Okay? Now, the second way, which is the second step, is inverses and determinant. It's easy part. Now, inverses and determinant, as I told you before, we know that any x, or for example, let's say from x times x, what's happened here? We just add the x's. For example, let's say this n, m, so n plus m, right? Okay, so how about if I have xn plus x minus n? So what's the answer will be? X n minus n is equal 0. So x to the power of 0, anything to the power of 0 is equal what? 1. Okay? And we know that any negative power can be written as 1 over x to the power of n, right? So now if I say x times 1 over xn, so the answer is equal 1. Why is equal 1? Because, okay, if I simplify x times x to the power of negative n, and here is already n, so the answer is equal negative 1, okay? Because n minus n is x to the power of 0, which is equal 1. So the same idea that we did here, it works with the inverses. Okay, so now as you can see here, 1 times 1 over 1, which is a, sorry, a times 1 over a, similar to a times a to the power of negative 1, which is equal 1. So the inverse of matrix, we know that a, matrix A, times the inverse of matrix A is equal what? Is equal 1. Okay? But because matrix has a dimension, it could be 2 by 2, it could be 3 by 3, it could be 2 by 3 or whatever, or 3 by 2. So we have different type of matrices, right? So how can I get 1? So focus on this. Matrix A, okay, times the inverse of matrix A, I will get row echelon form. Okay, again, if I have matrix A times inverse of matrix A, okay, I will get also row echelon form. It depends on the dimension of the matrix, if it's 2 by 2 or 3 by 2, 3 by 3 or whatever. Okay, so don't forget, matrix A times inverse of matrix is equal to row echelon form. Okay, now I hope you understand this. Let's take some example. Verify an inverse matrix. Now, let's verify if A and B, or let's say B is inverse for A. Okay, let's verify this. Or B inverse to A, or A inverse to B. Okay, how we can identify they are inverse? I told you, if I multiply matrix with any other matrix and they get row echelon form, sorry, one. So let me use this. If I multiply matrix and they get, if I multiply two matrices together and they get row echelon form, so of course this matrix and this matrix are inverse. Okay, now let's multiply them. So negative 3, 2, negative 2, 1, and times matrix B, 1, negative 2, 2, negative 3. Let's multiply them. And as I told you how to multiply them, okay, first step, you need to identify the dimension. Dimension is 2 by 2, here's 2 by 2, so they are equal. Now the new matrix will have 2 times 2, so 2 rows and 2 column, okay? So now let's multiply every single row with every single column. So negative 3 times 1 is equal what? Is equal negative 3 plus 2 times 2, which is equal 4. Then after that, negative 3 times negative 2, which is equal 6. Then 2 times negative 3 is equal negative 6. After that, let's continue. We have here negative 2 times 1, which is equal negative 2, plus, okay, 1 times negative 3, which is equal negative 3. Then the last one is negative 2 times 2, negative 2 times negative 2 is equal negative 4, positive 4, plus, okay, 1 times negative 3, which is equal negative 3. Now let's simplify this. Okay, so negative 3 plus 4 is equal 1, 6 minus 6, 0, negative 2 plus, this one should be not negative 3, this one should be 2, okay? So the answer here is equal 0. Then after that, 4 plus minus 3 is equal 1. So as you can see, is this row echelon form? Yes, so A times B is equal to B times A, which is both of them are IN. IN means row echelon form, okay? Yes, okay, it's inverse. Okay, now it's your turn. Try to solve these questions. Okay, it's easy. You just multiply if you get row echelon form, so it's inverse. If you didn't get row echelon form, so they are not inverse. Okay, now how we can find the inverse of the matrix? So let's read the question. Find inverse of A if it exists. If it does not exist, write singular. So if there is an inverse, so we write yes, exists. If it's no inverse, so we write singular matrix. How to find the inverse of matrix? Okay, so to find the inverse of matrix, first thing, we need to multiply the inverse. Okay, we need to multiply, the matrix times the row echelon form. Okay, the matrix A is A, negative 3, negative 5, and 2. So this one, and we write row echelon form 1 0 0 1. Okay, so this one should be 1. Now what I have to do, now I need to follow the 6.1 lesson to make this matrix row echelon form. Okay, now let's solve this matrix. Now I need to make this matrix 1 0 0 1, which means I need to make this value equal 1, and I need to make this value equal to 0. So this one should be equal 1, and this one should equal to 0. Now let's do it together. Okay, how to make this value equal 0 and how to make this value equal to 1. First step is to make this one equal 1. I need to divide row 1, okay, row 1 by 8. So if I divide row 1 by 8, so this one has become 1, this one will become negative 5 over 8, this one will become 1 over 8, then 0, negative 3, 2, 0, 1. Okay, so this is the first step. Now I made this value equal to 1. Now I need to make this value equal to 0. So row 1 with row 2. Row 2 has negative 3. This is 1, so I need to multiply row 1 with 3. Then we add it with row 2. Okay, so the new matrix will be 1, negative 5 over 8, 1 over 8, then 0. So 3 times row 1, which is equal 1, plus minus negative 3, which is equal 0. Then 3 times negative 5 over 8, plus row 2. Row 2 is equal 2. Now let's simplify this. So the answer will be 1 over 8. Okay, then let's continue. 3 times row 1. Row 1 is equal 1 over 8. Okay, plus row 2 is equal 0. So the answer is 3 over 8. Then 3 times 0 plus row 3 is equal 1. So the answer is equal 1. Now I made this value equal 1. I made this value equal 0. So now I need to make this value equal to what? Equal to 1. And I told you, if I need to make the value equal 1, I need to multiply by the inverse, the reciprocal. So the answer will be 1. So what we need to do here, we need to multiply row 2, okay, row 2 by 8 over 1, okay, or just 8, okay, because the 1 over 8 stay, okay. Now let's multiply 1, negative 5 over 8, 1 over 8, and here is 0, then 0, and then here it will be 1, then 8 times 3 over 8. 3 times 8 is equal to 24. 24 divided by 8, which is equal to 3. Then here it will become 8 times row 2, which is equal 8. Now as you can see, I need to make this value also to equal 0. And to make this value equal to 0, let's erase this, okay, I have to multiply also with the reciprocal. So row 1 should be multiplied by 8 over 5. Okay, so now let's do it. Okay, sorry, not row 1, I mean row 2, sorry. Let's do it now. So row 2 multiply with the reciprocal, which is 5 over 8, then we add it with row 1. So 5 over 8, okay, times row 2, which is equal 1, plus row 1, negative 5 over 8. So the answer now it become 1 0 0 1. Okay, then let's continue. Row 2 is 5 over 8 times 3 plus 1 over 8. So the answer will be 2. Okay, now let's continue. 5 over 8 times row 2, which is equal 8, plus 0. So the answer will be 5. Okay, so now I have 3, 8, 2, 5. So this is, as you can see, I made this side is row echelon form, and this one is the inverse. So as you can see here, okay, if you look here from the first step that we did, okay, here it's 2, 5, 3, 8. Here it's 8, negative 5, negative 3, 2. So do you see any, or do you notice anything? Okay, so you can notice that we are flipped between A and D diagonally, and we switch the sign for B and C. Okay, so this is the this is the way how we can find the inverse. There is an easier way to find the inverse actually rather than this. How we can find the inverse. Before we finding the inverse or show you how to find the inverse, okay, let me just show you how to find the inverse for question B. So to find the inverse of a question B, I'm going to apply the same rule that I did. 2, -3, -6, okay, then 1, 0, 0, 1. But as you can see here, okay, if we solve or we follow the same step, we will get no solution, okay, because this equation has no inverse. Okay, this matrix has no inverse. Why? How do we know that? I will show you how do we know that. Okay, after you solve these equations, okay, try to solve this equation first, okay, and using this, okay, using this slides will help us to know that it's not an inverse or there is no inverse. So the rule of finding the inverse is written here, okay. To find the inverse of any matrix by 2 by 2, we need to follow this matrix. So this one is only work for 2 by 2 matrix. So let's say I have a matrix A equal A, B, C, D. So I have A matrix and I have A, B, C, D. So to find the inverse of A, I need to find first det. What det A mean? Det A means it's a shortcut from determinant. So I need to find the determinant and I need to multiply it by the matrix A, but it will not be in the same order. The order will be changed. So we're going to flip or switch diagonally. So D will take place of A and A will take place of D. And B and C, we are going to flip flip the sign. So we're going to change the sign. So change the sign. If B was negative, it will be positive. If it's negative, if it will positive, it will be negative. Okay, for B and C. Now, what is det A? How we find det A? Det A is, there is a rule for det A is 1 over A times D. So we multiply A times D minus B times C. So we multiply B times C. Then we write the rule D minus B minus C A. Then, so this is how we can find the determinant. Okay, I hope you understand this. Let's apply the rule. Let's apply the rule for the first equation. So first step, let's find determinant A. Det A. To find determinant A is 1 over A times D minus B times C is equal 1 over A is 2 times D is 4 minus B is -3 times 4, which is equal C. Let's simplify this. You will get 1 over 2 times 4 is equal 8 minus, okay, -3, sorry, this is -3. -3 times 4 is equal -12 plus, so it will be plus 12, okay. So the answer will be here 1 over 8 plus 12 is equal to 20. So now det A or determinant A is equal 1 over 20. Now let's apply the rule. A -1 is equal 1 over 20. Multiply with the matrix. Let's switch now diagonally. 4, 2. So we switch between 4 and 2. Then we change the sign for B and C. So this one is negative, so it becomes positive. This one is positive, it becomes negative. Now it's a scalar multiplication. So we're going to multiply 1 over 20. Okay, by every term, 1 over 20 times 4, 1 over 20 times 3, 1 over 20 times -4, 1 over 20 times 2. Let's multiply them together. Inverse of A, to multiply a fraction with a number, we just multiply with the numerator. 4 over 20, 3 over 20, -4 over 20, then 2 over 20. So this one is my matrix. Now simplify the matrix, okay. Just divide, anything can be divided, okay. So 4 over 20 is 1 over 5. 3 over 20, there is nothing can be simplified here. -4 over 20, -1 over 5. 2 over 20 is 1 over 10. So this one is the inverse of A, okay. I hope you understand this. Now, let's go back to the question that I told you here. There is no inverse or no solution. Let's do and apply the rule from the first step, from the first time, okay? without applying this formula. Let's find the inverse of A. Inverse of A is equal 1 over A times D minus B times C, and we switch D, A, negative B, negative C. A inverse is equal 1 over 2 times negative 6 minus 4 times negative 4, negative 3. Then we switch negative 6 to negative 4 and positive 3. Now, let's simplify. A inverse is equal 1 over negative 12, and here it will become positive 12. Then we keep the same thing. Now check. A inverse is equal negative 12 over 12 is equal 1 over 0. Oh my god, 1 over 0 is undefined, does not exist, is infinite. So A inverse is not exist. Okay, is not exist. Why? Because I can't multiply 1 over 0 by the matrix. So that's why this one here, we call it singular. Singular means no inverse. Okay, don't forget. Singular means no inverse. Okay, now let's do this question here also together. So let's always find determinant. This determinant is not exist, so of course there is no 1 over 6 times 6 minus b times c, which is equal 4 times 9. As you can see, 1 over 36 minus 36, so it's 1 over 0. So also this one is what? Is singular. Okay, singular. Okay, now it's your turn. Try to solve. I'm sorry today, but because I think the screen is lagging, that's why. Okay, so now try to solve these two questions. It's easy to be solved. Okay, and if you need any help, please ask me. Now, how can we find the determinant of 3 by 3? To find the determinant of a 3 by 3, okay, you need just to follow the rule. The rule said, okay, let me write the rule for you here above. Okay, or let me show you here down. Okay, now look, this is the determinant to find a 3 by 3 matrix. Okay, so to find a 3 by 3 matrix, you need to follow this rule. Now, the rule said, let's say I have a matrix A by 3 rows with a 3 column. How to find determinant, det A? To find determinant A, first thing, you need to take the first element and you need to hide all the elements on the same row and in the same column. And you need to multiply this determinant by this 2 by 2 matrices. Do you see what I did? So I took A1 multiplied with B2 times B3, C2 with C3. So this is the first part to find determinant. Now the second part is, let's erase this. Okay, we need to take the second element. We remove everything on the right and on the left, and we remove everything on the same column. So the new matrix will be 2 by 2, which is B1, okay, B3, C1, and C3. Okay, so this is my new matrix. Then the last one, A3. So A3, we cancel everything with the same row and in the same column. So this one will be my new matrices, which is represented here. A3 multiplied with B1, B2, C1, and C2. So this is the new matrix. Then after that, don't forget the first sign is negative, the second sign is always positive. This is the most common mistake between all the students. They forget the sign, which is the first one is positive, which the second one is negative. So this is the way of solving or writing the rule. Then after we write this determinant, after we writing this, what I have to do? What should I multiply? What should I do? Okay, first thing, you need to multiply diagonally. Means you need to multiply, you need to multiply here, okay, B2 with C3. B2 with C3, then minus, okay, continue, B23 with C2, B3 with C2. Then you multiply them, okay, you find the answer, then the answer should be multiplied by A1. This is the first step. Now the second step is to multiply B1 times C3, so as you can see here, minus B3 times C1, as you can see here, then you can get the answer. Okay, here. Then after that you multiply it by a2. After you get, don't forget to minus, because there is a minus here, okay, between this one and this one. Then after that you add it with the third part here, as you can see, which is b1 times c2, then b2 with c1, then you minus them, then you write the answer here, multiplied with a3, then after that you add it with the other, then you get the answer. Okay, so this is the rule. I think you can understand, it's easy to apply. So now let's do it here. So the first step is to take -3, we cancel everything in the same row, same column, we take this is the new matrix. So this is the first step. Okay, then second step is to take 2, let's change the color, sorry, take 2, cancel everything on the right and the left on the same column. So this one here and this one here are my new matrix. Okay, then the last one, and let's use the below the red one, we take 4, we remove everything here, we remove this, so this one is my new matrix, so this one here. Then after that, what I have to do, I have to multiply diagonally, -1 with 0, -1 with 0, minus 2 with -2 times 4, we write the answer here. Then we simplify them. Okay, after that we multiply it by -3. The same idea here, 1 times 0 minus 1 times 2, then we write the answer. Okay, sorry, not here. So the answer will be only this one here for the red one, and this one for, okay, for the orange one. Then the last one is for the blue here, which is this one here, which is 1 times 4, and -1 here. Then after that we get the answer times by 4, then we get this. So the final answer will be 32. Okay, so the determinant for C is equal 32. I hope you understand this. Now try to solve this to find the determinant, okay, for a 3 by 3 equation. So here is 0, does not exist, here it's 9, and this is the inverse of matrix. I hope you understand. This is the end of the lesson. Try to solve these equations. Have a good day. Bye-bye.